Okay, in this video we're looking at other features of lines, and what I mean by that is graphing lines and then finding all their features, but then also checking where the points lie on a line, both algebraically and graphically. Let's have a look. So the equation of a line is y equals mx plus c, which you may have seen before. M is the slope and c is the y-intercept. So if I take a line like this, 2x plus 1, the slope is 2 and the y-intercept is 1, you can read those straight off the equation. Graph the line. So this is what a graph might look like. Make sure you draw up your axes, chuck arrows on the end, and put y and x. If I've got a y-intercept of 1, then that means that here at 1, I'm going to have my y-intercept. There it is. Now, what does it mean to have a slope of 2? Well, a slope of 2 is going to look like every time I go across one square, I'm going up by 2 squares. So for example, that dot will be on my line. I can do it again. I can go across by 1 and go up by 2. Now that dot will be on my line. And if you just keep lining that up and connecting the dots, you'll eventually get yourself a lovely line, which has a slope of 2 and a y-intercept of 1. Let's draw that in. There we go. And there we go. There's that line. Make sure you label it. So this is y equals 2x plus 1. And there's your line. So the other thing we'll probably need are little units on our axes. So 1, 2, 3, 4. It wouldn't hurt to go down to the negative numbers, -2, -3, and so on. -1, -2, -3, just like that. Now you chuck the arrows on the end of your line to show that it does keep going on forever. They're really important, as well as the label. I will dock marks in a test if you forget some of that stuff, so it's really important. Okay, find the x-intercept. Well, there it is. Looks to be at about -0.5. I'm going to put that in there as a guess, and then we're going to work it out properly. So a good definition of the x-intercept, which you should know, is it is when y equals 0. That's basically how we define an x-intercept. By the way we define a y-intercept is it's when x equals 0, same thing. So let's put the equation in and we'll see if this works. We've got y equals 2x plus 1 is our equation. And I was supposed to have y equals 0. So 0 equals 2x plus 1. You see there I've just replaced y with 0 because y is 0. Now, how do I get x on its own? Well, I'm going to have to start by getting rid of this plus 1, and I do -1 to both sides. So I'm going to get -1 equals 2x. Now, how do I get rid of the 2? I divide by 2. So let's say x equals -1 over 2. Hey, my guess was right. The x-intercept is -0.5. Or if you really like decimals, -0.5. Okay, cool stuff. Now, next thing we want to do is check whether each of these points lie on the line. So 1, 1. Let's draw that in. 1, 1 sits about here. And it looks like maybe that doesn't lie on the line. So at this point, I'm going to stop us and we'll have a look at Desmos, because Desmos can graph this stuff. Y equals 2x plus 1. Would be our line, and we can see the x-intercept's at -0.5 and the y-intercept is at 1. Every time we go across one square, we're going up 2 squares. You can also graph the point 1, 1, and indeed that does not lie on the line. So let's see what else we can graph. What other points are we looking at? 2, 5. So if I look at 2, 5, I believe it's that point up there, and it looks like this does lie on the line. 0, 1 is going to look like 0 on the x, 1 in the y. And it looks like that point will lie on the line. So we can tick that one off. 1, 0. I don't think that one will lie on the line. No, that's off the red line. So no, it does not. Now I really just want to show you how to do these algebraically because it's pretty important. So if you want to check whether like 1, 1 lies on the line, what you need is the equation of the line. So that's y equals 2x plus 1. And we're taking the point 1, 1, meaning that x is 1 and y is 1. So let's look at our left-hand side, which was y. That just becomes 1 because y is 1. Let's look at our right-hand side. That was 2x plus 1. So that's 2 times, let's see, 1 plus 1, which is 3. Now we compare. Does the left-hand side equal the right-hand side? It does not. 1 does not equal 3. and that is why 1, 1 doesn't lie on the line. Whereas if you have something like 2, 5, our left-hand side would be our y value, which is 5, and our right-hand side, it's supposed to be 2x plus 1, which is 2 times 2 plus 1, which is 4 plus 1. Oh my goodness, it's 5. Do these 2 points match, 5 and 5? Yep, they sure do. That's why 2, 5 lies on the line. So you can do it algebraically, and you can do it just by graphing it and having a look. There's a few ways around this. The main thing is slope, intercepts, and checking if points lie on lines.